All right, so take a look at these problems that you did on your warm-up. And check your answers. As you're looking at these, some pretty interesting patterns start to come about. Like, for example, some of you might have noticed that the number outside and the number inside, 3x, 7x, 6x, and 4x, is often the same number. It kind of falls apart, though, when it's not 1x by 1x. When it's 2x by x, this box doesn't match the outer number. 5 times 2x makes 10x. 3 times x does, because this was a 1x. You have to pay attention to the coefficients of all the x's because it affects what's happening inside the box. But there's a bigger pattern that happens. It's a pattern that I didn't notice for a long time. And it has something to do with the diagonals of each of these multiplications. For example, if you were to take x squared times 21, and you were to take 3x times 7x, they would both get a diagonal product of 21x squared. Sorry for the messy writing. If you did that with this one, x squared times 24 and 4x times 6x, both of those would have a product of 24x squared. Likewise, 2x squared times 15 and 3x times 10x, both of those make 30x squared. So one of the keys to what I'm going to teach you today has to do with the fact that the product of both of these diagonals is the same. Interestingly, the products are the same, and the sum of this diagonal is always going to be your middle term. The middle term is the sum of these two. The product is 24x squared. The middle term, 13x, is the sum of these two. The product is 30x squared. Now, I don't think I'm describing this quite well, but it's okay. We'll get there. As you look at this pattern, I need you to start thinking about our little buddy here. Remember our diamond problems? Our diamond problems had a product that we were looking for and a sum that we were looking for. For example, if I wanted to get the product of this middle one, 24x squared, to match and have a sum of 10x, the only way I could do that is 6x and 4x. Those are the pieces that go here, which means the diamond problem is going to help us determine how to split up the number of x's that we have. Because if we had 10 x's, you could have 2x and 8x, you could have 5x and 5x, but to get these diagonals to have the same product, it's got to be 4x and 6x. There's no other way to keep the product 24x squared. So that's what we're going to use today to go backwards. We've been going this direction. Well, today we want to go this direction. It's called factoring. And that is what your lesson is going to be about, factoring. All right, so let's factor x squared plus 7x plus 10. When I'm asking you to factor something, what I'm asking you to do is I'm asking you to tell me if this is the total area of this rectangle. I want to know what are the length and the width of that rectangle. I'm asking you to identify these two pieces. Now, the length and the width. Here's what we know. We know that every time we've done one of these problems, x squared has always gone here. And the 10 little units, those were down here. The question is, how do we split up the 7 x's so that we get the same exact product that's on this diagonal? Remember on our pattern just from a second ago. So I know that whatever goes here and here has to add up to 7x. Well, if you look at our problem, that's the middle term. And the 10x squared, which is what this has to also multiply to be, right? If both of them have to have the same exact product, then these two boxes have to multiply to match 10x squared in this problem. So my product has to be 10x squared, and the sum is the sum of these two boxes, the total number of x's. So I'm going to say the sum has to be 7x. Now, prior to this, all of our diamond problems, we've done a product of 10 and a sum of 7. Well, that would be 5 and 2, right? As long as I put in the x's, in order to get x squared, I need 5x, 2x. That would give me the x squared. And 5x plus 2x would have a sum of 7x. So these are going to be 5x, 2x. Now, it doesn't matter where you put the 5x or the 2x. You can put the 5x here or down here, and you can put the 2x there. One of the other things that I noticed from the previous example, let me go back here, is that the values that are out here are the greatest common factors of their row or column. What I mean by that is, if you look at these two boxes, the greatest common factor they share is x. If you look at these two boxes, the greatest common factor is 7. These two boxes, the greatest common factor is x. These two boxes, their greatest common factor is 3. So the outside dimensions are the greatest common factors of their row or column. Even here, look at this one. The greatest common factor of 2x squared and 10x, well, they both have a 2 and they both have an x, so this has to be the greatest common factor. Once you know this, then the top part just has to be the x that gives us x squared. If this is 2x and this is 10x, that has to be 5. Let's see how that works over here. The greatest common factor of my top pair is x. If this is x, then this has to be x, because x times x is x squared. If this is x, this has to be 5, because 5 times x is 5x. If this is x from above, and this is 2, 2x would give me the right box. And here's how you check your answer. If this is 2 and this is 5, and you get 10, that's your check mark happy face. So the answer is x plus 2 by x plus 5. Not too hard a problem. This is called factoring. Now, let's do one more example. Let's say I wanted to do, let's see here. Okay, let's say I wanted you to factor x squared minus 6x minus 16. All right, so we're going to start with our rectangle. If it's trinomial, we'll just do a 4-section rectangle for that, since that's where we can begin nicely. And this will be x squared, because that's where the x squareds go. And this will be negative 16, because of that minus. And then I need a diamond. I'm just going to use an x here. If I want to have the product of the diagonals match, then I need negative 16x squared as the product. This is why I've been saying all along, focus on the product. And then the sum of these two boxes, it's going to come from that middle term, so that'll be negative 6x. Now, if the x's part's confusing you, just focus on negative 16 product and negative 6 sum. So, let's see, 16 is 1 times 16, 2 times 8, and 4 times 4. Do any of these have a possibility of getting a 6? Oh, this one could. if 8 was negative, so let's go negative 8x positive 2x, and let's double check. Negative 8 times 2 is negative 16x squared, and negative 8 plus 2 is negative 6x. So these are right. So negative 8x positive 2x. The greatest common factor of my top pair here is just x. If this is x, in fact, I'm going to change my color here. If this is x, then this is x. And if this is x to the left, this has to be minus 8 to get minus 8x. If this is x, this has to be positive 2 to get positive 2x. And my check, positive 2 times negative 8, is negative 16. Check my happy face. So my answer is x plus 2 times x minus 8. Okay, you've got some work to try on your own. Go do the problems that are in your activity for today. Have a great day, and thank you for listening.